Okay, so today we are in the middle of a prime raid, first of all. So, you know, you'll see not very much on the screen. You'll see hearts on the screen for a good while. And we are going to talk about ring buffers. We're not going to just talk about them, we're actually going to write the code for them. But first, let's read the article that we wrote last time, and we shall go from there. What do we get a redeem for? A posture check? Is that what that says? I think Stream Manager is broken and it's not even showing me things. Who knows? That could have been redeemed like 10 minutes ago. Whatever. Okay, so ring buffer. An array-based buffer with efficient access at both ends. In the last article, we faced the limitations of the array list, namely that operations at the front are costly. A ring buffer, also known as an array buffer or circle buffer, provides constant time access to both sides of a sequential series of data while using a contiguous memory allocation, or buffer, wink, wink, underneath. While most ring buffer implementations are fixed size, Rust's stood, we say stood here on this stream, collections VecDec is a global ring buffer designed for general purpose use. How about it? You love efficient access from both ends. So do I, Ryan. All right, ring buffer. The first thing we need for the ring buffer is a contiguous memory allocation. Thankfully, we have implemented one in RawVec. While RawVec has the capability of growing, we just want a fixed size allocation that is specified at initiation. This does require a few small changes to the original implementation of RawVec, specifically adding support for RawVec with capacity, which we also need to do today. Unlike the vec or array list that we're used to, the last element in a series of data can have a lower index than the first when using a ring buffer. We can visualize the difference between how an array list and a ring buffer utilizes the underlying memory buffer in this pseudocode. Can we say buffer any more times than we have? We probably could. And here's an array list. So the point of this is these are the values you've added, right? This is the capacity of your memory buffer underneath. So this is how an array list could be represented, or in general is. All of your actual used elements are at the beginning of your memory buffer. And a ring buffer, those elements could be any place, any place in the ring buffer. It could look just like this, but it can also look like this. And that's why ring buffers are special. The alerts never end. I know. It's hilarious. Kyle timed out Nightshade. Did Nightshade show up? Hey, Nightshade. How's it going? Poor Nightshade doesn't have mod. Here. All right. First streamer I meet that comes from Rohirrim. It may seem unusable in this form, but the logic to calculate the actual index into the memory buffer is simple. In the above example, the head is at index 6 and the tail is at index 2. See what I'm saying? Okay. Index 6, index 2, right? However, from a user's perspective, the head is at index 0 and the tail is at index 5. And I'll show that in a second, what I mean by that. Just like the array list above it. To calculate the actual index from the perceived index, we simply use modulo. You can also use a bit mask here, but we're just using modulo. So a ring buffer offset equals head plus offset modulo capacity. Accessing the fourth element, the value 5, let's get that up here, in our above example, ring buffer index 4, 6 plus 4 modulo 9 equals 1. And that's how we get that 5 out of our ring buffer. Can I convert to 1 bit? Yeah, I'm sorry that this does not have 1 based indexing. I could have switched it, but actual index calculation has never been tried. So true, Trav. Bitmask would be faster. Yeah, it is more performant. If you're building this for performance, you should use a bitmask. If you're building this for people to understand what's happening, then you might as well use a modulo. Leah Sim 619, thanks for the sub. I appreciate it. You got all the emotes now. Look at those beautiful emotes. Those could be yours too, for the low price of $4.99. If you're building this for perf, don't do it. Okay, real story. My homegrown array list is faster than Rust's Vec. Real story, not on purpose. Why? Because it probably doesn't work for every type. That's probably why it's faster, because it doesn't work for every type. $5 a month, exactly. Since we are using a fixed size ring buffer, what happens when it fills up? It depends. For this implementation, we will continue to write data to the ring buffer, keeping only the latest n writes where n equals cap. That's short for capacity, in case you're wondering. This is useful for cases where retaining the latest n elements, extra space. What the hell did I do? No, it's not an extra space. It's just not monospaced. Look at how dumb that looks. Hopefully it doesn't look that dumb. Maybe if we make this, no, it's still there. What is happening with this space? Okay, is sufficient. A few examples include recent activity logs, slow motion photography, and undo redo behavior. Another option is to not allow data to be overwritten and instead check if the ring buffer is full before writing. This is useful for cases where there is a reader and a writer process, and the writer has to wait for the reader to consume and make space for new writes. An example of this is an IO queue used for real-time data processing. Yeah, it's a really good point though, Trav. I don't think a lot of people think about it. Like the array list is generic, but I think it's because I don't have any special handling for things like zero size types. So there's kind of like an assumption that the type is sized. And I think that is partly why my Vec is faster, but I didn't actually like go through each piece to see why my Vec's faster. I just found that out. The N in the following space were in a different font. Is this really did they do something stupid to me? Is this code? Oh, it was a code space. I bet I tried to make the N code and I made the space code instead. Skill issue. Classic. Good call out. Thank you. Good one, Raiden. All right. And finally, implementation of ring buffer with pushback, pop front, and an index trait implementation, which we're going to do here in a second. And that's in the to-do. Okay. Now with our ring buffer written, we see we're looking into the future right now. We're scrying. We have an array-based FIFO queue, overcoming the challenges of array lists from the last article. Sometimes the algorithms and data structures we write and study don't have a lot of practical application, but ring buffer is definitely an exception, with broad applications across programming disciplines. The source code with tests is available on GitHub. Next time, we will implement quicksort and bubble sort for ArrayList. How about it? Oh my God, we just caught up to when Trav subscribed. We just caught up to that. That was a very long time ago. These alerts are literally going to go forever. I don't care. I'm fine with that. I'm drinking it in. I mean, it's basically the same as actually doing it, right? Yeah, exactly. Good to do comment right here. Okay, so the first thing that we have to do is the adding to our raw vec. We have to implement raw vec with capacity, this little guy. So let's go ahead and do that. Okay, let me make sure I have a clean state on this branch, and we're good. And let's go into our raw vec. So this is our raw vec as it stands. Once it loads, there we go. This is our little raw vec. We got to wait for Rust Analyzer. Rust Analyzer's really trying here. Okay, all raw vec has is a pointer and a capacity. Right now we just have a new method on it. We have a get capacity method basically, and then we have a grow, and that's because we're using it for our array list. So we need to add a static method for with capacity to be rusty, and with capacity is going to be a use size, and this is going to return a self, and we'll see how much I decide to change here. Let's see. Maybe I should just create a little method that does this sort of thing, but just takes capacity as a, yeah, probably takes capacity as an argument. So what we'll probably do is let's just init the raw vec here to start with. So we'll just do a little raw vec. Actually, can I just do self new, I think, because I can just do this, right? I'm not an expert at Rust, by the way, in case you're wondering. Scry, are we playing Magic the Gathering? Oh, I've been spotted. I've recently started playing again. Okay, and then we're going to do something to our RV, and then we're going to return it. And that should get rid of our little squigglies there. How do you find split keyboards like that for gaming? I mean, any of them you can use for gaming. I use this for gaming. I don't game that much. We're almost caught up to the alerts. This will end eventually. Okay. And then we're going to want like a grow to capacity sort of deal. So let's go down here. We don't want that to be public. I don't remember why I made this public. I probably just wasn't thinking. Does that make sense? No, I remember why I did it this way. Yeah, nope. This is fine. We won't make this one public. Grow to cap. And this is gonna take, why am I in a weird, what happened to you, Vim? This isn't Vim, by the way, but don't tell anybody. Here we go. We're gonna take a cap use size. We're not gonna return anything. And we're just gonna get all this stuff. So here, all we're doing is actually creating a layout and a capacity. For the old layout. So I think what I want to do is change this to be like self.grow to cap, and then just say new cap. That's probably what we're going to do. And then we're going to just take all of this code and put it up here. No NeoVim unsub. Yeah, I have NeoVim installed. I've just never moved it over to it. So in my day job, I write Clojure. I am a paid, I forgot to tell Prime that when he rated me, but I am a paid Clojure developer. We exist. It's an Ergodox Easy Blue 3. You can also hit keyboard if you want to, the command, if you want to get the deets. My point in bringing up Clojure is that it's a Lisp, and it is generally historically enjoyed inside of Emacs, by the way. So this is actually Emacs with the evil mode, which just means Vim motions in Emacs. And evil mode is very well done. I can basically do everything that you can do. Just about. You know. It's not so bad. Obviously I can't use like NeoVim plugins and stuff, but you know, the Emacs OS, it helps. There's a whole lot to the Emacs OS. I have never once scried and kept. That's funny. Once in a while I do, but I'm just starting to get back into Magic to become an even bigger Uber nerd than I am. Okay, so maybe we just change new cap to okay. Maybe we just call this new cap and then we don't have to change anything. What if we just did that? And then old layout was actually just something that we created ourselves and didn't have to think about. Huh. New cap. If self.cap equals 0. I'm trying to decide if I want to take the old layout as an argument or not. I guess we will. Just so I don't have to change this code down here. We'll just take old layout as an argument. Oh, look at the LSP actually being nice and telling me what I should type this. How about it? Yeah, option layout, and then we can just change this to old layout, and that looks pretty good. And then here it just means, oh, we haven't actually done this yet. Okay, let's read through this code and make sure we don't have to change anything else. So basically, to change the size of this memory buffer, we have two things. If we have an old layout, which means we've already allocated a memory buffer, then we just have to reallocate. If we don't have an old layout, that means we didn't allocate anything, which means we alloc for the first time. And we just update the pointer and update the capacity. All of this looks pretty good to me. I don't see any problems with this. So I think this is good. So with capacity, I already know what state it's in. So I can actually just pass none as the old layout. It's pretty exciting. So we're just going to say rv dot grow to cap. And we're going to put cap and we're going to say none. Okay. And now we have with capacity, except I forgot to mark RV as mute. Okay. We're so good at this. Is he building this for the game Rust, or is Rust referring to something else? Yeah, it's Rust language. It's a programming language. Yeah. It's a classic H to the G. It's a good Emacs joke. I still enjoy it. This is all very interesting, but I have zero idea. Hey, I have one idea of what's going on. So you're not too far away from me. Okay, so we implemented with capacity. All of this looks good. Let's just make sure LSP is not lying to us. And we'll just run a cargo build real quick. Warnings are fine. We like warnings. Unused import. Super. Okay. This is just what I'm used to writing in my tests, and I don't actually need them, clearly. So now let's just create our ring buffer RS file. And we're going to copy one line because I always forget it. It is going to be pretty similar in some ways to our vec code, array list, vec, same thing. So, you know, there's that. What's up, John? Okay. And what do we need in our ring buffer? Let's just write it in a comment up here so I don't forget what we're actually implementing. We're going to write I already forget. See, I already forgot. I have to look at my own article. I write the article for myself. What is it? It's pushback, pop front, and index. I knew that. I'm so good at this. Pushback, prop front, and index straight. Okay. All right, so our ring buffer itself, we really only need to keep track of the head, which is going to be a U size. And then we have our buff, which is going to be our raw vec t. I forgot the generic. There we go. And let me think. Do I need anything else? Oh yeah, this might help. This might help. I either need to have a tail or I need to keep track of length, right? One of those is fairly important. So we'll just do len. Head buff len. We're pretty happy with this. We should be good. All right. So we're gonna impl t ring buffer t, and of course we just start with our new, which isn't gonna take any arguments. That's a lie. We are going to take a capacity because that's actually somewhat helpful. So this isn't very rusty, so I'm thinking I'm actually going to just say with capacity. I could have a new that like I just choose a capacity. It's a possible. I could do pop back. So since we have access to both sides, I can do pop back, but because I'm trying to finish it all in one stream, I just want to keep the interface small in case I hit, grug moments. Dylan, thanks for the sub. 9 months of forgetting to remove your CC from Twitch. That's fair. Totally fair. Dylan's here. Hey, Don. All right. So let's do a little with capacity. And this is going to be ring buffer. We're going to say head. We're going to just start with head being 0. And then we're going to say buff is a raw vec with capacity. And that's going to be cap. And we are going to have to put our generic argument in there. Like that. And then our len is 0. Okay. So all this means is technically there is no head, so head being 0 is a lie. But we're just going to have to make sure we check our length in order to do this correctly. Nice. Cherry MX Browns are coming back around. Nice. See, if you just keep something long enough, then it ends up, being in style again, right? Isn't that how this keyboard works, Dylan? Don't you agree? Okay. What else do we need? Oh yeah, I already wrote it. I wrote it so I didn't have to think. We're going to do a push back. So pushback is just going to take a mutable reference to self, and it's going to take an actual value, and it's not going to return anything because that's how Rust likes to do things. Okay, so this is when we actually have to write things to memory using unsafe, since we're managing memory ourselves. So let's think about this. Since we're pushing back, like obviously if it was like at the very beginning, it'll be interesting to see. Let's just think through this. This is also why I write the article. That way you don't have to remember really, really hard things like this. All right. So if this is the formula to calculate tail, then to calculate where we actually want to put anything to, it's going to be the same argument. So even if we don't have anything in our length, this will be the same. So even if it's 0, right? And we can just double check that because sometimes I'm stupid. Okay, sometimes I'm stupid. So today I learned Meta's articles are just as journal entries. Nice. Right. So if 0 plus 0, okay, modulo, nice how he said modulo, but typed ampersand, modulo anything, doesn't matter what it is. This better equals 0. Otherwise, I'm going to be pretty disappointed in myself. Okay, we're good. We're so good at this. Okay, so all we have to do is we're actually going to need that for a few other things. So let's just create a little method that's private. And what do we want to call it? If you're using a bit mask, usually people will call it mask. I'm just going to call it index. I think that's fine. And this is just going to take a reference to self. Yeah. And it's going to take an index that we want, right? And it's going to return an index. Okay. And that's where we're going to put this little thing where we say self.head plus we're getting there. We're so there. We're so good at this. Okay, self.head plus I modulo, I did it again, modulo self.buff.cap, right? It's modulo the capacity of our memory buffer underneath. Okay. I don't know the precedence on these operators. I can't remember in Rust if it's actually specified or not, which operators take precedence. So we're just going to leave the parens there just to be sure that we're not screwing ourselves over. So if you do -1 modulo 10, is that -1 or 9? Wait, what do you mean? Oh, I actually don't know. Prophet's here to teach me. She's actually my CS instructor. Yeah. See, percent is not modulo. Yeah, it's rem. Are you coming in here, Ray March, with an actually it's rem? Is that what you're saying? What is this Rust REPL? It's kind of crappy, but it's called iRust. No, it is relevant. It's fine. But we call it a modulo. I actually didn't know that. I knew that's true. Crap. It's true in a lot of languages where modulo isn't really modulo. Yeah. No, it's actually a great point, Ray. I was just messing with you. I was making a joke. Rust has rem Euclid, which behaves like modulo. Yeah. Good deal. Cool. It's great information. Okay. So if we want a certain index, we say self.head plus I modulo self.buff.cap. And in this case, where we're going to push this to, we'll just call it I here, is going to be self.index self.len. Okay. And now we actually have to do the work of pushing it to the back, like writing the memory, right? So let's see if I can remember how to do this. I don't think it's that hard. Okay. So the first thing that we have to do is get our pointer. And let's see. We'll say let p equal self.buff.pointer. And then we need our offset of I. And I want to say it's just add, right? What do you mean there's no match? Oh, that's right. I have to do an as. I have to do self.pointer.as pointer. And then I think I have an add, right? What do you mean no match? Is Rust Analyzer just not working? Oh, I know it's not working. I forgot to include this in my library. Nice try. Now are you going to work? Why aren't you giving me completions? Am I just forgetting how this works? Self.buff.pointer.as pointer. Let's just delete this for a second. There we go. That's not what I wanted, but it's okay. I'm pretty sure this is correct, but we're about to find out. Yeah, lots of plastic, lots of plastic. That's what I just said. So, I mean, how cool is a cucumber? Really, am I? No. That's what it is. Yeah, it is OCaml. I didn't want to bad talk OCaml if I was wrong, Prophet, but it is an OCaml. Where rim is called mod. It's so funny. It makes me feel better though, because I'm dumb sometimes. I don't have a CS degree. Use of undeclared type raw vec. Well, that would do it. I just had to look here. It might help if I actually imported code that I wanted to use. Is that an idea? Is that something that we could do? Especially if we actually took it from the right module like this. And then maybe, look at that. I didn't even need the LSP. I did all of that to find the LSP and I didn't even need it. Okay, so now because I like it better, we're gonna say use stood pointer. And then down here, we're going to say pointer right. This looks right. This looks good. And we're going to write to that P. And we're going to write that val. And we're going to love it. Okay. We have written the val using unsafe. I wish we were done, but we have to remember to actually increment. This is a mistake right here. This is just a ring buffer, which is a certain type of data structure. Blame. Self.len plus equals 1. Yes, actually, this is correct. But technically, no, we're just pushing to the back. Never mind. It's correct no matter what. It's correct. We don't have to change the head. We're just pushing to the back. We're not pushing to the front. We're super happy about this. We just have to update len. Okay. We're so ready for this. Let's do pop front and then we can write some tests. Nice try, Michael. Who's that? Who's Michael? Oh my God. All right. So here's pop front. And that's just going to be, it's just going to be our head. And then we have to update it, right? That shouldn't be so hard. That shouldn't be so hard. Let's see. Let P equals. Actually, we don't have to do any of this because we actually just want to do pointer read. There we go. Self.buff.pointer.as pointer.add. Just kidding. Just kidding that we don't need to do this. Let's do this. Let I equals self.index. Oh yeah, let I is just head though. We do need the add, but it's just head. I don't have to do. I almost calculated head using head. That would have been pretty dumb. Okay, so pointer read is here, and that gives us a. I think it just gives us a T, right? So if we didn't have anything extra to do, we could be done here. Now, I'm just trying to decide how I want to do this. Okay. We're going back and forth between implementations because that's how we do. and self dot len minus equals 1. And I just like, no, that was not where that space was supposed to go. Okay, that looks better. And then instead of saying self.head, we're going to say I. We're reading. We have a copy. We're super happy about this. Okay. Yeah, ring buffers are super useful. You know what? Blame? This is going to surprise you, but I am just about to publish this article on ring buffers. If you hit that Bing blog right now, you can actually, what is this again? Is it like this? Is it like that? No, I don't think so. It's just mod tests. And then I just do a little test like this. And then I say ring buffer works. It's just the blog command. Thanks for the alert, Juan. This isn't published yet, but once it's published, if you want to sign up, it'll get emailed to you. But you can also look at all the previous posts, and it's all about data structures in Rust. I don't go into like super depth. It is a little bit for people that have experience with some of these things, but like I think you can get a gist. Like they're short. I like it because it's short. I like my own content because it's short, because I don't have the patience to read long fucking articles sometimes. Okay. So let's just say we've got our little RB here, and we say ring buffer with capacity, and let's just do 9 like our example, just for the hell of it. Okay, we'll do 8 because not doing a power of 2 is kind of dirty. Yeah, stdlib is really good. I think there's a way. Isn't there a way to get Substack as RSS? It's a good question, John. There it is. /feed, apparently. So for me, that should be metame. Nice. There you go. Let's add that as a command. All the young people are like, what's RSS? Cool. All right. Okay. Here we go. It does sound like some kind of STD. I was like, I read it as stood, and I was like, what do you mean it sounds like some kind of stood? And I was like, oh yeah, that doesn't mean that in every circle, does it? All right. Okay, let RB equals ring buffer with capacity 8, and let's start actually pushing some things onto this ring buffer. So since we're, I forgot the size, I forgot the type, because let's just do U8 for funsies, and we'll just push a couple things onto here. Let's do 9. So good. And we'll do one more, which is going to be 7. Really good numbers. I have 255 to choose from, and I choose 1, 9, and 7. Let's just do a little mute on here. What are you mad about with ring buffer? Failed to resolve use of undeclared type ring buffer? Oh, because I don't have my... Did I not make ring buffer public? That also would help. That's why. If it's public, I don't need super. I think. No? It still does that. It's so dumb. Then why does the compiler give me all the warnings that super's not used when this is exactly what I do every time? See, then I have super there and it's like, oh, this is unused imports. Really annoying. Because you use it only in a test. Yeah. But then it says it's not imported unless I do that. Doesn't make sense. It's fine. Okay. What were we gonna say? We were gonna say assert eq, and we were gonna say rb dot len is 0. I just realized an error. What happens if the ring buffer has no elements on it? This is what happens. Okay, so if self.len equals 0, we want to return none. Otherwise, we do all this stuff, and this needs to be a sum. Where'd my cursor go? And there we go. Okay. Nice. Okay. rb.pop front is none. Okay. We push some values and we say assert eq rb.pop front. Since we're pushing to the back, these should all be in order. So this would be sum1. Let's just do a length check to make sure I didn't do something dumb. We're so good at this. Okay. rb.len is 3. Okay. And then 9, and then 7. Okay. FIFO. That just means first in, first out, by the way. Allow unused is my jam. That's fair. Above mod test. Is that what I need? Should I just do that? And then I don't have to allow unused. I had definitely fucked that up, didn't I? Okay. Why does it... Is this the thing that has to be at the top of everything? Isn't it like... Is it because of the bang? Maybe there? That's it. There is a config test, isn't there? Isn't there a config test? Oh, maybe that is that the thing that I screwed up on all my other ones? Like that's already in config test, and because I didn't put it, that's why I'm getting the... That's what it is. I started writing that and I was like, oh, I didn't need it before. And now I'm realizing that that's what it's for. Okay, good call. Thank you, Rusty people. Okay, so then we pop all of these in order, and let's just pop one more, make sure that we get a none out of it. Pop front none. And just for fun, let's make sure that we're, I mean, if we're not, some of these won't work, but I like kind of like exploring the behavior in the tests a little bit. The head after this thing should actually be at 1, right? And hopefully I did that right. Here we go. That reminded me that I didn't do it right, which is if, let me think. If self.len equals 0, we're returning none anyway. But what if there's just one element and we're popping the front? That's what it is. If self.len, yeah, that's it. If self.len equals 1, I think I'm right. Then we don't want to increment self.head, right? Yeah. That's right. I didn't do a len access function. That's it. Yeah, I think that's great, Joe. I do appreciate the reminder on that. I had that before and I just forgot. All right. This looks pretty good. Let's see if we got a first try. I don't know if we did. We'll find out. Let's do a little cargo test. Ring buffer. Pressure's on, guys. Did I get a first try on ring buffer in Rust? Just so you know, on my array list, I had a few times where we there was possibly a double free. And then I also managed to get a seg fault at one point. So we'll see. We'll see if I learned anything. I don't know why it's decided it needs to build from scratch, but that's fine. Beautiful. It would have been nice, but you know, this is me we're talking about. Okay, panicked. Maybe it's just a bad test. Let's see. Where did we fail? Line 77, left is 0, right is 1. Okay. Line 77. Let's see. On pop front. It's really effing close to first try, okay? It was one character. It was just one character. It was just a little bit like I was supposed to do this. I remembered to add this conditional while I was writing the test. I just wrote the conditional on the inverse. First try. All right, we're pretending that's a first try. First try enough. Ring buffer in Rust. Push back, pop front. And now we can write an index trait implementation. Let's do one more, because this will, let's see. Let me think about it. Oh yeah, this will be good. You guys will like this. Okay, so I could think that I'm okay. All right, you guys didn't see this. This is definitely not Emacs failing. Definitely not. That had nothing to do. My args out of range 60 had nothing to do with Emacs failing. All right. If you use NeoVim, it wouldn't break. Damn it, did I close the wrong one? I think I closed the wrong one. Fuck. I think I closed the wrong one. Yeah, I closed the wrong one. Nice. I usually recover from that pretty fast. Come on, just go over it. Stop click. Oh, stupid Mac. Stupid Mac window management thinking it knows what I want. All right. Let's see. This isn't 100% where it's supposed to be. It's good enough. All right. It's fine. Okay, let's write one more test and we'll see why in a second. And this is going to be a string ring. A string ring works. And it's going to be a little simpler than the other one, but we're just going to do with capacity 5. Let's just do 2. Because, I mean, what's better than a ring buffer with a capacity of 2? Okay. And then what are we going to say? We're going to say rb.pushback. Hey. rb.pushback. You. Okay. And then rb.len. We're just going to do this. And you're about to see why I wrote this test. No, it's a fixed size. It's a fixed size buffer. There is some handling that we didn't do yet, which is what happens when it's full. I didn't actually handle the case when it's full, and we'll show that in a second too. Okay, so this looks good, right? We think we're doing great. Except, let's see what happens when we run Miri, which is a Rust memory leak detection tool. It's probably why I had to recompile when I did tests, just because I have to use the nightly toolchain for mirroring. Just a classic chill time watching Rust build something. I don't believe he has leaks. I have faith in streamer. There's a leak. There's got to be a leak. We're about to see it. Nice. Memory leaked. Rust heap. Size 3 of line 1 allocated here. All right. So we have a leak. Okay. We didn't have a leak before. We don't have a leak in our integers, but we have a leak in our strings. Yeah, it is Miri's amazing. It does a lot of cool checks. So why did this happen? And that's because, of course, these are all on the stack, right? These aren't so kindly all on the stack, right? Like it has its own allocation that it has to free, right? And so what happens is because we're using raw pointers and stuff, we have to impl drop. Impl drop or ring buffer T. And let's see if Rust Analyzer is kind to me today. No match. Is it because it's pub? Usually Rust Analyzer is kind here. There it is. It doesn't like to do it if I've typed anything. Okay. So this is pretty simple. All we have to do, there's different ways that you can do this, but the easy way based on our implementation is just to say this. While let sum equals self.pop front. So we can leave it like this and Rust will automatically deallocate everything for us. So is backseating allowed? It depends. Like Ray, I think you know quite a bit about Rust, and these are definitely not about like making the optimal perfect data structures. But if there's like just little tips that you want to like provide and be like, hey, check this out, or you know, we could also do this, that's all good too. I'm totally happy for that. So like backseating's like softly allowed, soft backseating, you know? Okay, so we fixed our memory leak with our little drop. If we wanted to be more explicit as far as like what this is soft backseating. That's right. Nice plush backseat. All right, we're getting off topic, aren't we? That's getting into, if we wanted to be like explicit, we could call like a little drop V here, but they do functionally the same thing. All right. So I'm just going to leave it with the one-liner because it's cute. And we'll go there. Okay, so we fixed our memory leak by actually implementing drop for ring buffer, and that's nice. So the next thing that we have to fix is this little problem here. Our capacity is only 2. So what happens if we push another one? A couple silly things happen. Number 1, this ends up being 3. And our little rb.pop front, it's going to give us hey. No, it's not going to give us hey. It's going to be some, this is what we want it to be, right? Let's go with what we actually want our tests to do. Well, we actually don't want it to be that, but it's okay. Let's just illustrate this real quick. We'll just keep Miri on here just to make sure we don't make more dumb mistakes. Nice. Yeah. Miri gives me too much information. So that's annoying, isn't it? Undefined behavior. Memory access. Oh yeah, right. Because I was thinking that I was just going to wrap around because of the way that I implemented this, but we're actually, because we're using length, we're actually outside of our allocation, right? So we have an alloc size of 48, and then we're trying to get to len 3, right? We're trying to get to offset 3 from our original pointer. Obviously that doesn't work. So we actually didn't even have to write these tests because this is going to the bad place. So let's see if we can get up here and fix that. Okay. So what is it that we need to do? A couple things, right? We have to check if our capacity and our len match, right? So, how do we want to do that? I think what we want to do up here is Maybe we just want to change it to this little I thing. The problem is we're going to have to change, like, whether we increment len down here and stuff is going to depend on if we do this stuff, right? This is kind of like an optimistic incrementing, but if the data structure fucks up here, we're fucked anyway. So it's not like it really matters that much. We are going to do a little bit of this. We're going to say if self.len equals self.buff.cap. All right. Any functional programmers are going to absolutely hate this code. But this is what we're doing. I mean, everybody's probably going to hate this code. Let's be real. So this is our like happy case. I could have just used X there, but instead I went into insert mode because I'm silly sometimes. And then what happens if we are full? In this case, I'm just going to overwrite. I'm just going to take, do I use the rawvec implementation for the Nomicon? I wrote my own rawvec implementation. It is very, very similar to the Nomicon implementation, except I don't handle every edge case. Like I assume I don't handle like zero size types and stuff. But yeah. Let's see. If you use my rawvec for other things, you could probably get some nice undefined behavior going on. We'd get into UB territory. But as far as just like a little implementation, it's not bad. Okay. Let I equals if self.len equals self.buff.cap. What do we want to do? We don't want to increment index length. I mean, we actually just want to increment head. Okay. We're going to increment head. Now, if your capacity is 1, then you don't ever want to increment head. But hopefully you're not creating a capacity of 1. Oh no. What if you were creating a capacity of 1? Do I want to handle this? Should I just handle that here? I don't think I'm going to. Don't create a ring buffer with a capacity of 1, okay? All right. If self.len equals self.buff.cap, self.head plus equals 1, we're going to go to the next one, but we actually need it to wrap around, right? What if self.head is actually there? So we actually have to do our special thing again, right? We have to make sure this is actually correct. And that is actually a problem that I did here too. You can't just increment head. You can't increment head like this isn't a circular data structure. What am I doing? What am I doing with my life? All right, self.head equals. So it was like a fake first try only because of, the way I wrote my tests. Okay. Self.head equals self.index, self.head plus 1. Okay. And we're just going to copy that line for 21 up. And that's what we actually want. We're incrementing head. We're so happy. That's our only index that we store. So we're happy about that. And what are we actually pushing to? Oh, I just thought of that. I just thought of a way I could just fix this. I could have actually just fixed this right here. Let's forget about this. 1 second. We're gonna make this a little bit nicer. We're gonna make this a little bit nicer. We're gonna say self.index self.len. Yeah. This is good. This is really good. Okay. Now we have a couple options. Since we're writing first, we can write to this, and then we can say if self dot let's see, if self dot head equals I, right? It's the other way around. Rue0Q, thank you for the follow. If self.head does not equal I, self.len plus equals 1. And that really just means that we're at capacity. It's actually, I kind of prefer the other condition. If you liked it, then you should have put a ring buffer on it. Nice, Antonio. What's up? How's it going? Split keyboard for the win, for sure. I kind of like the expressiveness of the other way though, which is to say if self.len equals self.buff.cap. I did equals again when I meant not equals. That's the theme of the stream. The theme of this stream is using the wrong, using the opposite of what I mean. Okay. If we're popping front, yeah. This looks good. This looks good. This looks good. Now let's see where we're actually at. What we actually want when this happens is we should find that guys has overwritten hey. And we shouldn't have a memory undefined behavior anymore. Let's see if I did it right. I made so many changes that I'm not sure I did it right. Okay, what did I do? rv.pop front sum 7. Oh no, I fucked something else up. Let's see what it was. Okay, let me see where I went wrong. Ring buffer line 60. Did I change anything here? What did I change? I changed what self.head is, but I didn't change anything else about this function. What did I screw up? I changed how pushback works. Okay. Let's think about this again from scratch. Let's make sure pushback is doing what we want it to do. Okay, so when we push something onto our ring buffer, we get our index. Our index should always be the special index of self.len, which is meaning if we have a ring buffer of 2 and we say self.len is 2, it should actually give us 0, right? So self.index, self.len should be 0, right? You know, something along those lines. It should wrap around. That's the point. The point is it should wrap around. Let me just think that makes sense. Self.index, self.len. I said it should always be 0. Obviously, that's not what I meant. Why am I thinking that this is the back? Let me think about this. Oh yeah. No, this works. Because if I give it self.len, it's going to do self.head plus I modulo self.buff.cap. Right? That's going to work. It should work every time. Antonio coming in with the with the jokes. Okay. Let's just like double check this real quick. What do we want? We want head, we want cap, and we want eye. All use sizes. We're going to return a use size. ChatGPT made them? Oh no. Scary. And then, hey, Suyash, what's up? We're going to say head plus eye mod cap, and that's our whole function. Okay. And so if our head is at 0 and our cap is 5 and we want to push to the back, which in this case is 5 because we're full, I would assume that this would give me 0. It does. Okay. And if we want to push to 4, this should give me 4, etc., etc. Okay. Very exciting. And if it head is at 1 and we want to push to 5, this should give me 1. And it does. Okay. So this logic seems pretty good. We have the offset that we write to. We write to that pointer. And then if self.len does not equal self.buff.cap, oh, you know what? I think I thought of another potential memory leak situation, since I'm actually just writing over the pointer. I'm not doing anything special. Yay, pointers. Solving DSA, have you tried exorcism? Yeah, I've seen exorcism. I just like doing my own thing. I mean, it's nice to have all the tests written for you. You know, that part's nice. So let's go back to the Miri output and see where we went wrong. So far, this says what? Using uninitialized data, but this operation requires initialized memory. Okay. This indicates a bug in the program, caused UB, and this is specifically in rb.popfront sum 7. And so rb.popfront after 197. So this is when it's popping what is just offset 2. So let's see what's actually happening here. If self.len equals 0, that shouldn't be a problem. Let I equals self.head. Let's just think about this. Yep, that's fine. If self.len does not equal 1, if self.len does not equal 1, self.head equals self.index, self.head plus 1. Is there a problem with this little line right here? Let's think through it. So if we have a little guy, here, which is 7xxx adult rated, just kidding. Okay, this is essentially the state of the memory buffer at this point where it's failing. If self.head, yeah. And then len here should actually be 1. And head should be not 0 because we've popped off. This is actually, okay. This is the state of our ring buffer right here. Okay, let's just print some shit out. Print line debugging. Pop front I is I debug. And then that's also head. So we'll just leave that like it is. And then we're going to say print line. Actually, we can just print line head no matter what after this. Print line pop front head. Okay, we're getting somewhere. Except this has to be self.head, which means I have to put it as an effing argument. Self.head. Okay. We probably want to just look at len too, just for the hell of it. Len, killing me here. Is a len? No, I have to do this too, don't I? Self len and self len. Okay, that looks better. All right, let's see what happens. Okay. I forgot to run no capture. Might be better to do this without Miri, but we'll just see what happens. Okay, pop front head 1, len 3. Whoa, that's here we go. Pop front I 0, len 3. Then we have pop front head 1, len 3. That's correct. I1, len 2. Pop front head 3, len 2. Pop front I3, len 1. Yep. This is looking fine. Pop front head 3, len 1. Okay. I3, len 1. What's wrong here? Why is it I3 and not I2? What happened? What happened here? Why are we getting 0, 1, and then 3? 0, 1, and 3. What did we do? Okay. Self.index, self.head plus 1. Okay, so after here, we got head 3. That's the problem here. This head 3 is the problem. How did we get to head 3? Let I is is 1. Self.index, self.head plus 1. Oh, it's still based off the old head. That's got to be the problem. Is that the problem? Let me just think about this. Oh yeah, Miri is really, really great. If you're using unsafe. If you're not using unsafe, ideally you're not needing Miri. But yeah, it gives a lot of information. Okay. So obviously I fucked up. I just have to figure out where that was. I mean, this is probably the most sus code here, and this is what I changed. If self.len does not equal 1, we're going to set self.head, self.index, self.head plus 1. So we're just trying to increment and allow it to wrap around. But for some reason, when we're at I1, 1 plus 1 is not equaling 2. It's not equaling 2. Okay, this is exciting. Let's print, and it is actually on this pop front for sum 7. So it's not even on the string. I'm not even wrapping around in this case. So how did that happen? Okay. I think we can get here. We can do it, guys. If you're not, yeah, I mean, you got to feel alive, Antonio. That's why we use unsafe here. All right. Head 1, len 3. So then the next time we're at I1, len 2. And then somehow with I1, len 2, it calculates this. I guess we should just put the cap in there just to be like 100% sure about what we're doing here. Because self.head should be, in this case, still 1. And getting the index of 1 plus 1, also known as 2, from this calculation should not have any problems. Let's just add capacity and see if it shines light on our own problems. Nice. Self.buff.cap. And let's see if I can remember to do this. No, I was so close to doing it right. Self.buff.cap. Okay. All right. See you, Antonio. Thanks for dropping in. All right, let's see. Our capacity is 8. So how do we end up getting 2 let's see if we have this right. Yeah. How do we get self.head plus 1 Is there some weird thing where I should not be using self.head right here? I don't think so. If this fixes it, I'm going to be kind of mad. Yeah, we could look at self.index again. Okay, it doesn't fix it, which I'm actually happy about. Because then I would really not trust Rust very much if that fixed it. So this should be self.head plus 1. Okay, let's look at this real quick in terms of our index function. Somehow from index, we're ending up with 3 given these. given I plus 1. So here I would end up being 2. And then we'd have self dot head. Oh. Oh, I see it now. Okay. What did I do wrong? What did I do wrong? We can't add head because we want the real index. We want the real index. It's not self.head plus 1. It's 0 plus 1. Also known as 1. Also known as 1. That's the problem. I was doing the calculation twice of self.head plus 1. Okay. That makes me feel better. That makes me feel better. Okay. Self.head equals self.index 1. Yeah. Yeah. That's the same as saying self.head plus equals 1 and actually wrapping it around. You're exactly right, learner. It's a ring buffer, circle buffer, etc., etc. Okay, so that's the problem. Okay. We're so happy that happened because now we understand where we went so wrong. Okay, so we'll still have some test failures if I'm thinking about this right, but we won't have the same test failures, and that's what matters. Okay, what did we end up getting a failure on? Right here. Panicked at 100. Now we can get back to what we were actually trying to do. So this says left is 1. Oh yeah, actually, no, that's correct. Maybe we did do everything that I meant to do. I actually wanted to check here before we popped guys off to make sure it was 1. So did I fix this? And I just forgot that I fixed it? That would make a lot of sense. All right, what did we do now? This should be a memory leak, right? Memory leak. Okay, cool. So now we're on a memory leak and I know why, and we're so happy. So because of the way we have this written, because we're dealing with all these special things, when we're actually overwriting, we have to drop our old value if it's droppable. Now I could check. There might be like an optimization here where I could do this so that I don't have to read the current head pointer every single time and drop it. But we're probably not going to do that. Okay. So basically what we're going to say is if self.len equals self.buff.cap, it means we're overwriting, right? And so we have to drop. I could just put this in like a bool, but that would be okay. I feel like Ray, you might know this. Isn't it complicated to find out what is drop and what's not? Pointer replace. That's probably what I've used before. I forgot about that function. Does that do exactly what I want it to do? Rust. No, I went to Rust reference. I just want the docs. Give me the docs. You cannot test if something is dropped. That's what I thought. Pointer replace. I could have just looked in the LSP, but I like reading docs. I'm old. I'm an old person. I like reading docs. Move source into the pointed dest, returning the previous dest value. Neither value is dropped. Right, since I already know the value, then this will just magically call drop on it for me. Love it. Absolutely love it. Okay. Yeah, I would imagine, Ray. It is kind of a frustrating thing, but pointer replace means I don't have to do this. Now, what if, oh, it's not valid though for reads and writes. So I actually still need the if. I still need the if. Rust is a little bit complicated. There's a learning curve. Okay, so basically what we're going to say is if we're at capacity, we're going to do this. I knew a ring buffer would take me more time than my other data structures. And we're going to replace P with val. And we love it. We're happy about it. And I believe this will take care of everything. Yeah, I mean, I don't love it. Maybe read then write is clearer than replace if you write it like this. Because I'm used to functional programming, I'm used to writing if else. Like it took me a really, like even a month ago, I was having a really hard time writing code like this because I'm just so used to working with expressions and not having early returns. So I'm just really used to writing if else for most things. It's just in my blood, I guess. Let's just give it a little bit of vertical white space and see if this fixes our memory leak. Water time. Sick. Memory leak fixed. We are wrapping around. Everything's working as we would expect. Not the most beautiful code in the world, but it's working. Let's take out our debug prints. Where am I actually using? Oh, right. I'm getting I first before I do this malarkey. This is fine. This is fine. I guess to make the code a little bit more uniform, I could not do that. That would be bad. I could put this up here since that's where I'm updating my length below, which I'm doing just for the implicit return. But that at least kind of makes these visually similar, which I like. Hey, thanks for the follow, Joe. I appreciate it. Okay, so our ring buffer works, our string ring works. Forgot the S there, which means we have a pretty clean implementation of all these things. The only thing left that I wanted to do is implement index. Since I said I was going to, it shouldn't take that long. So let's do index. Will Rust Analyzer do anything for me here? I'd really like it to just kind of fill this shit out. I always forget how this part works. That does not actually help, in case you were wondering. Okay. Index, and can I just say use size right there for ring buffer T? And I'm just going to peek at my vec implementation because it's going to be very, very similar. And by vec, I mean array list. Also because I wanted to try to make this video under 2 hours. Ba, 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 ba. Where's index? Here it is. Yeah, you can't just say index. Okay, it's output. That's what I couldn't remember. Yeah, we can do this, I guess. And we'll just grab that. This looks good. If index is greater than or equal to self.len, then we're going to panic. We're going to do an unsafe, except we need the real index, not this fake index. We can actually, it's going to be so ugly. It's going to be ugly no matter what. But if we go like this and we say self.index, oh, that's hilarious. I forgot that this is called index. So we're going to have to change the name of our other function. Function, what do we want to say? Something gross like this. Wrapped index. We could call it mask, I guess, if we really wanted to. And then let's just do this index. Let's say dot index. There we go. Wrapped index. Okay. Wrapped index is out of bound. Thanks for that. I really no, that was a terrible replace because I see what it did now. Oh, that was not good. That was not good. Let me look down here and then I'll be able to see it happening and I'll know if I typed it right this time. Dot index instead of an actual dot. Can I do this? Can I do that? I can. And then we're going to say dot wrapped index. Okay. That's a little bit better. Okay, self.wrapped index, and then that's the index we need to use here. Looks okay. And this looks fine, except of course this isn't in scope. Is it stood ops, I think? Is that right? Stood ops index. Yeah. Should we just do index mute since we're just copying my previous labor over and making small changes to it? Might as well. Okay. What don't you like about wrapped index? Yeah, it absolutely does take an argument. You're absolutely right about that. Okay, looks good. Oh, let me see what you said. If something pointer replace, else pointer right p-val. Yeah. Yeah, I get it. Pythagorean, you want some switch testing? Okay, we can do that. Give me 1 second. If you use command switch test or switches, you can see the switches available for testing. Let's just steal this index mute implementation from our array list. And probably won't work since rows functions or ZSTs, yeah. Let's see. Index mute use size for array list. No, we don't want that. We want ring. I can't type. Ring buffer. Okay, this looks okay, except we're gonna need this line. And any problem with this? Nope, this should be fine. Okay, let's see if this works. I don't fully understand the special case at pop front with lane does not equal 1. Yeah, okay. So let's talk through this and it will also help. Okay, so if it is if there's only one element, let me think about this. If we only have one element in a ring buffer, right? We'll go back to here. And we want to pop that. And if we say self.head equals self.wrapped index 1, I mean, I guess it doesn't matter. Essentially, I was like, well, we don't actually have to update the head then, right? And then this would still just be our head and the next write would happen here. So if we wrote an 8, then that would happen after we popped. But I guess the actual if condition doesn't matter. The only thing that felt funny to me, no, it's not like it just felt funny. It just felt like, oh, we don't have to update head. So why would we, you know? Yeah, it doesn't actually matter. It just means that we'd write 8 there instead, right? Yeah, it's a good point. I'm trying to think. I mean, is that write very expensive? Probably not. And it's not like this is a very optimized thing. So yeah, maybe it makes the code a little bit smaller, which I actually would be happy with, because already I think this is going to be pretty overwhelming amount of code for readers. So I think we can actually just do this. Yeah. Yeah. It doesn't actually matter functionally, right? Yeah. Let's just make sure our test pass. I don't actually need mirror no capture on this moment, but you know, we'll do it anyway. Okay. Did I make a certain, did this actually matter? It'd be really funny if it did. No, that's right. I haven't tested since I tried the replace. Yeah, that's right. That's right. Okay, constructing invalid value encountered uninitialized memory but expected a raw pointer. Pointer read dest. So this must be the read inside of replace. So they're already doing that for me. Huh, why? Why did you do this to me? Encountered uninitialized memory, but expected a raw pointer. Is there a condition on here that I didn't think about? Pushback self.len equals self.buff.cap. I guess I didn't check if I actually fixed that. Pockets. Thanks for the follow. Pointer replace p val, sure. RB dot push back u to string. This is actually just on the second one. Oh, that's surprising. So this is on the second one. Oh, because this is what I changed. I wanted it to be visually the same. I wanted it to be visually the same. But this is what I changed. I changed where I was updating len. That's where the logic error came in. All right, F it. I could change the conditional, but instead, we're just going to go here and put it back to where I had that code before. Need to do a quick message check. All right, we're good. Okay. Yay. Order of operations matters a little bit, in case you're wondering. I'm just going to leave it there instead of having to think through this because, I've been live coding for 2 hours in front of hundreds of people. It sometimes it takes its toll. So let me just show how freaking cool index and index mute are. Now, of course, this is not something like index mute is a little bit like, I mean, both of them are like, do you really want this on a ring buffer that's like, first in, first out queue? It kind of messes some of that stuff up. I could put it in the unsafe statement. You mean this little guy here? I could put that in there if I wanted to. I don't know why I would though. Oh, because of the else. Let's think about it. We're only incrementing length here. Oh yeah, that's nice. That's nice, Ray. That's a good one. See, this is a good example. You're actually excellent. You're actually excellent at soft backseating. Have you ever heard that before? Has anyone ever told you that before, Ray? You're very good at it. Let's just run those tests to make sure it works fine. You got banned once, so no. I mean, there's some people that come in and they're just like, oh no, you should write your test this way. And why aren't you doing this? And why are you stupid? Okay, I didn't say that, but that's what it feels like, right? And that's more like the point of, yeah, that doesn't feel good. That doesn't feel very good. Okay, so index mute, it's pretty cool because now, well, this is not index mute. This is just index. Now we can say RB0, right? And we can say something like this. And we can say RB0 and it'll be pretty. If you don't know Rust, this is one of the cool things about traits. And since we have references, that should be our test. It failed. That's fine. I forgot that I don't have to do that. Index is a little weird. Okay. Very exciting. Okay. And then we could also do things like this. Like instead of 7, we can just make sure our RB works. We can say RB2 equals 14. We just have to remember to change this test. And I just thought of a problem. You know what I just thought of? I actually thought of another memory leak that is in this implementation and in the other one. Are you guys ready for this? You guys already probably have seen it. Let's see. I don't have a test on use, so let's just change you real quick. Let's say RB0 equals meta dot toString. Yeah, you can ask a question. You don't even have to ask a question if you can ask a question. I mean, assuming what? There's no memory leak? Are you sure about this? Oh, it does it right for me. I forgot. There's no memory leak because it's just returning a mutable pointer. Yeah, it's not like proof, but I can logic it out. When it crashes, it says error 1 in something with Java runtime. 99% of the time, it's probably because you don't have enough memory in your JVM, because JVM loves memory. Other than that, I probably don't have any good pointers for you. Google, that's my pointer. You can try ChatGPT. See what ChatGPT thinks about it. Even the free version. Yeah, I was thinking because it was doing the same thing that I was doing, that I would need, that I had like, you know, a pointer right in here or something, but I forgot that it's just a mutable pointer. And so Rust does the right thing. I don't have to think about dropping types, dropping values, etc., etc. So cool. No memory leaks, most likely. Most likely. All right, sick. This was cool. We have a ring buffer. It seems to work. We finished the interface I wanted to, which is a simple interface. And that's why I set it to just these few methods. And, you know, a couple skill issues along the way, but not a million of them. Into iterator win. I did one on my array list. And that is when I got into double free and and other fun skill issues. Yeah. No, into iterator would be fun. The first ring buffer I implemented like a long time ago when I was learning Rust. So long ago, 6 months ago. I'm acting like I'm a Zoomer right now. Man, 6 months, so long ago. Just kidding, Zoomers. I made that interface pretty thick. I implemented quite a bit, including an iterator on it. Getchium ring buffer, but I don't think it probably has a memory leak because I don't remember if I actually tested it with anything like strings. Good times. Okay, ring buffer. Let's go. Beautiful. Thanks for tuning in. For those of you on YouTube, I'll catch you next time with some more data structures and algorithm.